Okay, looking at the 4.1 explorations that you guys did the other day, what did you figure out? First of all, what is a cubic function? How can you tell? X cubed. Cubic is x cubed. It's going to have an x cubed. Quartic is x to the fourth. Okay. What did you find out about their graphs?
I don't know if I did it right, but...
Well, all you had to do is type them into GeoGebra.
Wait, what were the two things?
Cubic and quartic. Cool. Okay, on which one? If it's x cubed, it's going to look something like this, right? Okay. What did a quartic look like if it was x to the fourth? Looks something like this. Okay. Cubic, quartic. You're going to have to understand what those graphs look like. Okay. So some of the characteristics of a cubic, you notice that if one side's going up, the other side is going down. And on the quartic, what?
Both sides are going either up.
Both sides are going up or both are going down. Okay. So now flipping over to 4.1, the actual lesson, what we're talking about here is different types of polynomials. Okay, and they give us a chart there, and they list the degree, and then they tell us the type, and then they give us an example. Okay, so if the degree is 0, this is a constant function. We've talked a little bit about constant functions. An example would be like y equals 3. Okay. The most common confusion with this is people don't think that there's an x there. Okay. There is an x there. It's just x to the 0 power. And we know that anything to the 0 power is equal to 1. So if I were to substitute, it'd be 3 times 1, which is just 3. Okay, so that's why it's not written. There is an x to the 0 power there, though. Okay. First degree is a linear function. An example would be y equals 2x plus 6. Second degree, we just finished talking about. Those are quadratics. Example would be y equals 2x squared minus 3x plus 4. Third degree, we just mentioned, is a cubic. That would be like y equals 2x to the third minus 4x squared plus 6x minus 1. What are you noticing about the degree? It's what, Cole? Okay, I get what you're saying, but it matches which exponent? If it's in standard form, it's the first one.
The highest one.
It's also the largest one. Okay? Your largest exponent is your degree. Largest exponent's 2, degree is 2. Largest exponent's 1, degree is 1. Largest exponent's 0, the degree is 0. Okay? So a quartic or a fourth degree polynomial would be like y equals x to the fourth minus 3x cubed plus 6x squared plus 3x minus 1. Okay, that would be just an example. Now, yeah?
Does it always need to be like every degree in there? Or
No, that's what I was just going to say. These could range, okay? It might be 2x squared plus 4. It might be 2x cubed minus 4x squared. It might just be x to the fourth. Okay? You don't have to have everything in there. Those are just examples of what they would look like in standard form with something at each one. Okay? Questions so far? Okay. So if I put something up here and I had an x to the 7th in it, and that was the biggest exponent, it would be what degree? 7th degree. Okay. So what we're doing here in example 1, they are giving us a function. They give me that f of x equals negative 4x to the 5th plus 7x squared minus 2. Okay, they want to know a few things here. One, they want to know, is this a polynomial? Okay, and right now everything I've showed you has been polynomials. I'll show you one in a minute that's not. Okay, is it a polynomial? If it is, what's the degree and what's the leading coefficient? And we'll talk about the leading coefficient in a second. Okay, there's nothing goofy about this though, right? Okay, if it looks pretty normal, hey, your exponents are good, hey, there's nothing weird going on with them, this is a polynomial. Okay, you're looking for weird things in the exponents that will make it not a polynomial. But right now, yes, this is a polynomial. What degree is it? The 5th degree. And then we're looking for what's called the leading coefficient. Now the leading coefficient will always be your front number if it's in standard form. Okay, well, if it's in standard form, the largest exponent's got to go first, right? So what's another way to find the leading coefficient if it's not in standard form? Find whatever your degree is, largest exponent, whatever number's in front, that's your leading coefficient. So in this case it is negative 4. Okay? If I were to change this 2 into an 8, the degree would be 8, leading coefficient would be 7. Good. Okay? Not too bad there, right? Okay. The next one, I have 0.5, give me g of x, 0.5x squared plus the square root of 3 x to the 4th plus 19. Okay. Now, something like this always trips somebody up with that square root of 3, and they want to say that it's not a polynomial. But the square root of 3 really is no different than this 0.5, right? That's a decimal. Agreed? So is that. So is this okay? Yeah, there's nothing wrong with that. So don't let a square root there trick you. Is there anything goofy with the exponents? No. So we're probably okay. This is a polynomial of what degree? Degree is 4. Leading coefficient? Square root of 3. Okay. So to be able to find the degree and leading coefficient, do you have to put it in standard form? No, not necessary. Okay. Still doing okay? All right.
The leading coefficient is always with the biggest exponent.
Yep, that's the nice thing about it. If you find your biggest exponent, your leading coefficient has to be attached to it. Okay? It's just 1, yeah. If I did this, if it was just plus x to the 4th, leading coefficient would be 1. Is that what you're asking? Yes. Okay. Next one, I have negative, they give me h of x equals negative x cubed minus 4x to the negative 4th minus 3x. Polynomial, not a polynomial. not a polynomial. Okay? You can't have a negative degree. Okay? Now, does that mean that this is not even possible to have? No. We could have this. Okay? We'll get into stuff with that later. Okay? But it's just not a polynomial. Okay? So the answer to this is not a polynomial. And if it's not a polynomial, then it does not have a degree, and you cannot find a leading coefficient. Okay? The last one I want to look at, k of x, and they give me x squared plus, minus 1, not that that really matters, plus 9 to the x power. Polynomial? No. If things look weird, it's not going to be a polynomial. Okay? If they look super goofy in the exponent, it's not a polynomial. Okay? You'll be able to pick it out pretty easy. To be a polynomial, a exponent can't be negative. It has to be a whole number. Okay? Whole numbers are 0 and bigger, no decimals, right? Okay? So what if I did this? What if I said this is x to the square root of 3? Polynomial? That's not a whole number. That's a decimal, right?
If they happen to put like square root of 9, will they like try and mess us up?
Maybe. They could. I'm not going to tell you no, because as soon as I say no, it's going to happen.
So like 1.3 is not a whole number?
1.3 is not a whole number. Your whole numbers are your counting numbers. 0, 1, 2, 3, 4, 5, 6, 7, so on. Okay? Questions so far? My rule has always been if it looks weird in the exponent, it's probably not a polynomial. Okay? It'll stand out. Okay? Taking a look at example 2, I'm just going to talk about this one really, really briefly, and then we're going to move on. They give me f of x is 2x to the 4th minus 8x squared plus 5x minus 7. They want me to evaluate it when x equals 3. What do you do? Damien, can you shut that, please, so I know you're with us? Thank you. You just plugging it in. Hey, that's literally all you do. Don't let them try to trick you or confuse you. If they say evaluate, you plug in. Now, I did have some people messing up because they were doing things in the wrong order, so you do have to be careful of that. Is it important that I use these exponents first?
Yes.
Yes. Is it important that I then multiply before I start subtracting or adding?
Yes.
Yes. Okay. Use your order of operations. Parentheses, exponents, then multiplication, division, then addition, subtraction. Okay. I'm not going to solve that all the way out. You should be able to handle that. Okay. The biggest difference here compared to what you've done in the past is now you're taking things to larger exponents. You're taking 3 to the 4th power. You probably haven't done that a whole lot. Okay. Can we plug in and solve? Okay. We're going to move on then. What we're looking at next is going to help us as we graph starting tomorrow. Okay. This next chart we're looking at is talking about end behavior of polynomial graphs. What does the words end behavior mean? So what's behavior? Like how you act typically, right? Okay, so we're talking about how or what this graph looks like on the ends of it. Okay, so when we say ends, I'm talking the left end and the right end. Okay, when my x is clear negative and when my x is clear positive is what we're talking about. Okay, what I want you to do right now is get out that paper that I gave you. This one, get it out. You should all have it. Does anybody not have it? Gage, do you have one? Did I give you one? Damien, did I give you one? Are you sure? There you go.
Thank you.
You can use those on tests and quizzes. Okay, so does everybody see where I'm looking? It's on the same side of standard equations of a parabola with vertex at the origin. That's at the very bottom. And it says end behavior of polynomial functions. Is everybody with me? Okay, so there's a lot of weird stuff going on there that you probably haven't seen before. The first one. Okay, I want to go through what all these mean. The first one on the top left is saying if my degree is odd, and actually I just want to do this. Okay, so I have a coordinate plane. If my degree is odd and my leading coefficient is positive, meaning maybe my degree is 7 and my leading coefficient is 6. Does that make sense? My degree is odd, my leading coefficient is positive. If that's the case, what I have below there is telling you what happens on the ends of the graphs. Okay? So when I write f of x, what is that really standing for? It's standing for my y values. So this is telling me my y values approach negative infinity. What's that mean? Yeah, but where's negative infinity? Up or down? Okay, so my y values are going down as my x values go
Down, also down.
okay, and x values don't go down, they go left. So what that means is on the left side of this graph, my y values are going down. Okay, as I go left, my y's go down. Okay, and then I go to the next row, and it says f of x approaches positive infinity, which means my y's go up as my x approaches positive infinity, which means my x are going right. Okay, so as I go right, my y's get bigger. Okay, so that top left, if my polynomial satisfied the fact that the degree is odd and the leading coefficient is positive, it would look something like this. Now, that doesn't tell us what's happening in the middle, right? Okay, we have no idea. If you want to draw these arrows on here, that's fine. Okay, you can do this on your sheet if you would like. Okay, we don't know what's happening in the middle though, right? Now, if it were a cubic function, that's not true, right? Yeah. No. If it were a cubic function, it'd look like this, right? Okay. As I go up in degree, there's going to be some other things that happen there in the middle. Okay, so I don't know what's happening in the middle, but I do know this is what happens on the far left and on the far right. Okay. Notice as we go through here, on each one of them, the top row, x goes to negative infinity, the bottom one, x goes to positive infinity. Okay, so that the top row on everything is going to be the left side, the bottom row will be your right side. Okay, does everybody get what I'm saying right there? Okay, we'll keep going, take more looks. Okay, I have the next one. If I go over to the right, my degree is still odd, but now my leading coefficient is negative. Bless you. Okay, so if my degree is odd, my leading coefficient is negative. On the left side, where does my y go? Up. It says f of x approaches positive infinity as x approaches negative infinity, meaning as my x goes left, my y is going up. What happens as x approaches positive infinity? Goes down. F of x approaches negative infinity as x approaches positive infinity. Okay, which hopefully what you saw with your cubic functions the other day makes sense, because a cubic is an odd degree, right? It's 3. And my graph on a cubic was either going to look like this, or it was going to look like this, correct? Okay, either way, they were going opposite directions when the degree was odd there. Right, Lainey? With us? Okay. So that's when your degree is odd. Could be a degree of 1, which would be a line, right? Does that still hold true on a line? Yeah, left side's going up, right side's going down. Okay. Would it still hold true if the degree was 5, 7, 9? Okay. I could do 51. This is still going to hold true because it's an odd degree. Okay. So the next one, as we go down to that bottom, those bottom two, my degree is now even. So like a parabola, right? A quadratic function, a quartic. Okay, I have an even degree when my leading coefficient is positive. On the left side, as x goes to negative infinity, what happens to f of x? It goes up. What happens to my y as x approaches positive infinity? It also goes up. I'm looking in the bottom left corner of our sheet. Does that look like it could be a parabola? Yeah, it definitely could be. And that makes sense what we talked about, because remember, if I had this parabola, x squared plus 2x plus 6, I know it's a parabola, right? So we all knew it was U-shaped. And I know that this a is positive, which means it would open up, correct? Okay, that's your leading coefficient, isn't it? Okay, what happens if I were to make it negative? It would go down. So, as I go to the bottom right, where it says my degree is even but my leading coefficient is negative, on the left side my y goes to negative infinity as x goes to negative infinity. But on the right side it goes also down to negative infinity as my x goes to positive infinity. Again, that does not mean that this is a parabola, right? Okay, because we don't know what's happening in the middle. If it was a quartic function, it'd look like this. Okay, so there's some other things that can be happening in the middle. But what I do know is if the degree is even and the leading coefficient is negative, both sides are going down at the end. Yes?
Okay, so you know how it does like a little up and down in the middle?
Yeah.
How come it doesn't do that like when you get to bigger numbers, like random? I don't get why that doesn't.
Every degree has a different rule of how it changes the graph. Is that what you're asking?
But I'm asking, like, you know it goes down over here. Why isn't there just like a little bump like there is in the middle? Like, why does it work out that it goes up and down right in the middle? Like,
Oh. I don't have. You're saying why? Why don't we know the rules for the middle as opposed like? Got no answer for you. Okay. So what we will do tomorrow, we will start graphing these, and what this will help you do is you'll make sure if you're graphing something, and let's say you just do the -2, -1, 0, 1, 2 like we always did when we graphed, right? And you get something that looks like this, and you stop here, this is +2. But we know that the degree is even and the leading coefficient's negative. So we know it has to come down over here somewhere, but your last point shows that it's going up. What you'll do then is you'll pick another point until you can make it go back down, because you'll know it's supposed to go down at some point. Does that make sense? Mm-hmm. Because if I were to just graph it and stop, I would assume that it goes like that, right? But if it's a quartic, I know it doesn't. I know it has to come back down at some point. And we'll just keep going until we find where it comes back down at. Okay? So we'll do 2 examples here of this, and then you can have the rest of the class to work on your assignment. They give me one function is -0.5 x to the 4th plus 2.5 x squared plus x minus 1. First of all, if I asked you the degree, you would tell me 4, and you would tell me the leading coefficient is negative 0.5. Okay, where on your sheet is the degree even and the leading coefficient negative? Bottom right. You say right, left?
Yeah, I did. That made sense in my head, but not.
Okay. Okay, so you're looking for your degree. It's even. 4 is an even number. And your leading coefficient is negative. So we're bottom right. So I know that my y goes down on which side?
Yes.
On the left side, yes. And it also goes down on the right side. Also, from the knowledge that we've got just over the last couple of days, you do know that it does one of those in the middle, right? Okay, we don't know where or what points it does it with, but we do know it goes down and then back up in the middle. Okay, so right now, today, this is all you're going to be looking for. They're going to want to know the end behavior of the graph. Okay. The end behavior. This is the end behavior, right? This is the end, that's the end. Okay? The last one I want to look at, stay with me guys. The last one I want to look at, and then you can work on your assignment, is g of x, and they give me negative 2x to the fourth plus 6x cubed minus 3x plus 11. Degree is 4, so is that odd or even? That's even. Okay, and the leading coefficient is negative. So what's going to happen to this one? The exact same thing, right? This one's going down and this one's going down. Okay, does everybody understand how to read this and what you're looking for? Hey, if you get to your problems and you're confused, let me know and I will come by and show you exactly what I'm talking about.